Humans are obsessed with time. We constantly worry about tomorrow, the next year, or perhaps the next century. But on a cosmic scale, a century is absolutely nothing. It is less than a microscopic blink of an eye. So, what happens if we fast forward? Past the limits of human history, past the life of our planet, and journey deep into the unforgiving, bizarre, and terrifyingly dark future of the cosmos. Welcome to the end of everything. Let's see what happens when time itself runs out. Let's start relatively soon. In about 5 billion years, our sun will run out of the hydrogen fuel that keeps it burning. It will swirl into a massive red giant, expanding so much that it swallows Mercury, Venus, and almost certainly Earth. Our beautiful blue home will literally melt into glowing plasma. A tragic end for us, but a completely normal, unremarkable cosmic event. Shortly after, the dying sun will violently shed its outer layers, creating a beautiful nebula and leaving behind a tiny, incredibly dense core, a white dwarf. A dead star, no larger than Earth, holding no nuclear fusion, just slowly cooling down in the dark. This is not just the tragedy of our sun, it is the ultimate fate of over 97% of all stars in the Milky Way. As we fast forward trillions of years, the universe enters a long, dark and quiet phase. The degenerate era, star formation slows down and eventually stops completely as the universe runs out of free gas. The night sky goes dark. The bright, vibrant galaxies we know today will fade into a pitch-black graveyard of dead stellar remnants. Cold, quiet, and dead. And out there in the absolute dark, the true apex predators of the cosmos will wait patiently. The black holes. Welcome to the black hole era. A time so far in the future that the number of years has more zeros than there are atoms in your body. The universe is now entirely pitch black, populated only by rogue black holes wandering the endless, freezing void. Occasionally they might stumble upon a rogue asteroid or a dead white dwarf, consuming it in a brief, violent flash of light. But these rare meals are just temporary interruptions in an eternity of absolute darkness and freezing cold. Temperatures drop to just a fraction of a degree above absolute zero. The universe is practically dead. In this desolate wasteland, you might think black holes would rule forever, the undisputed immortal kings of nothingness. But quantum mechanics has a plot twist. Even these monstrous gravity wells are slowly dying. Thanks to the brilliant work of Stephen Hawking, we know that black holes aren't completely black. They leak. To understand how a black hole dies, we have to zoom all the way in to the very edge of the event horizon. Empty space is never actually empty. It is constantly boiling with virtual particles, randomly popping into existence. These particle pairs normally appear, collide, and destroy each other in a fraction of a millisecond, balancing the universe's energy book. But if they appear exactly on the edge of a black hole, something bizarre happens. One particle gets sucked across the horizon, trapped forever. The other particle manages to escape into space. Because of the conservation of energy, the universe can't just create a free particle out of nowhere. The energy has to come from somewhere. The black hole itself pays the price. It gives up a microscopic fraction of its mass to create that escaping particle. This is Hawking radiation, but this process is unimaginably slow. For a black hole the mass of our sun to completely evaporate, it would take 10 to the power of 67 years. For a supermassive black hole, it would take a Google of years. A 1 followed by 100 zeros. So for an eternity, the universe is just a dark, freezing soup of shrinking black holes, slowly bleeding their mass into the void. But there is a catch. As a black hole loses mass and gets smaller, the evaporation process speeds up, and the black hole gets hotter. In its final millions of years, the black hole shrinks to the size of an asteroid, radiating immense heat. It is boiling away. In its very last second of existence, it is microscopic, but still weighs hundreds of tons. And then it dies, detonating with the force of billions of nuclear weapons. sending a brilliant flash of light across the dark void. But there is no one left to see it. No planets to illuminate. Just a solitary flash fading back into the eternal darkness. Over googles of years, this happens to every single black hole in the universe, until, eventually, we reach the final one. The last black hole evaporates. The final flash of light in the history of the universe travels outward and dies. And then, nothing. No stars, no black holes, no light, no heat, no life. Welcome to the final stage of the cosmos, the dark era. The universe is now just a dilute soup of photons and scattered subatomic particles drifting through an infinite void. Entropy has reached its maximum. Energy is spread out so evenly that no work can be done, and nothing new can ever happen. This is the heat death. The remaining particles are separated by billions of light years. They will drift aimlessly, cooling down towards absolute zero forever. In this frozen, unchanging wasteland, a strange philosophical problem emerges. Time itself begins to lose its meaning. Time is just a way to measure change. When entropy is maximized and absolutely nothing changes anymore, time effectively stops. So, is that it? Is nothing truly the end of the story? Not quite. Because quantum mechanics hates nothing. Remember the virtual particles that evaporated the black holes? Even in the ultimate heat death, the vacuum of space still has a baseline energy. Space is still randomly fluctuating. And when you have random fluctuations paired with an infinite amount of time, the rules of probability get very, very weird. If you roll the cosmic dice forever, eventually you will roll the exact, astronomically unlikely combination to randomly create an atom out of nothing. And if you wait even longer, out of pure randomness, particles could accidentally arrange themselves into an apple, or a piano, or even a fully functioning, conscious human brain, complete with false memories that exists for a split second before freezing to death. This incredibly creepy thought experiment is known as a Boltzmann brain. But don't worry, the math goes even further than that. In a truly infinite time frame, a massive quantum fluctuation could cause entropy to randomly reverse in a massive pocket of space. This is called the Poincaré recurrence theorem. The idea that any system, given infinite time, will eventually return to its original state, a random clustering of energy so unbelievably dense and hot that it mimics the exact conditions of our early universe. A new Big Bang, born entirely by mathematical accident from the frozen ashes of a dead universe, creating a brand new cosmos, filled with new stars, new planets, and eventually new life, a profound cycle of rebirth that ensures the end of time is never truly the end. So, if the universe is a simulation, does it have pixels? Let's take a look at a seemingly smooth, continuous object. Like an apple. To our human eyes, the apple looks perfectly solid. But if we grab our cosmic magnifying glass and zoom in, we see that it's made of cells. Zoom in further, and we find molecules. Zoom in again, and we hit atoms. For a long time, humanity thought atoms were the fundamental building blocks of reality, the ultimate indivisible pixels. But we were wrong. Dive into the nucleus of an atom, and you find even smaller parts, protons and neutrons. Crack those open, and you find even smaller, impossibly jittery little particles called quarks. Surely, quarks must be the bottom, right? The final, indivisible layer of the universe's source code. Well, theoretical physics has a terrifying answer. What happens if you try to zoom in past a quark? You eventually hit a hard limit, a physical wall, a scale so unimaginably tiny that space itself stops making sense. This is the Planck length, roughly 1.6 times 10 to the power of negative 35 meters. To put that in perspective, if a single atom was the size of the entire visible universe, the Planck length would be the size of a standard tree. At this microscopic scale, the smooth fabric of reality completely breaks down. Space is no longer a continuous, flowing river. It becomes a violent, boiling mess of chunky, discrete packets. Quantum foam. You literally cannot measure a distance smaller than the Planck length. It is the absolute minimum resolution of the universe, meaning our reality isn't infinitely smooth. It is fundamentally pixelated. Just like a digital screen, if reality is built on a digital grid, then movement isn't a smooth, continuous slide. Just like a character in an old 8-bit video game, moving through space means teleporting from one pixel to the adjacent one. In our universe, that means jumping from one Planck length to the next. But a computer can only update the screen so many times per second. If the universe is a computer, its absolute shortest tick is the Planck time. You cannot move faster than 1 pixel per tick. If you move 1 Planck length per 1 Planck time, you hit the absolute maximum processing speed of the universe. We call it the speed of light. No matter how much energy you use, you physically cannot go faster. The universe's server simply cannot render movement any quicker than that. But wait, it gets weirder. Think about what happens when a computer tries to process too much information at once. It lags. The frame rate drops, and things slow down. Over a century ago, Albert Einstein discovered something completely mind-bending. If you travel extremely fast through space, getting close to that absolute maximum speed limit, time actually slows down for you. We call this time dilation. It's a proven, measured fact of physics. To the rest of the universe, you look like you are moving in slow motion. But
we've allocated the server processing power into
Imagine
two
the
main
universe's
streams.
server
Movement
only
through
has a
space
fixed amount of
and movement
processing
through
power
time.
for every object. If you use up almost all of your allocated power just moving extremely fast through space, the server doesn't have enough power left to process your movement through time. If you hit 100% processing speed, the speed of light, your clock stops entirely. To a photon, time literally does not exist. So, is Einstein's legendary theory of relativity just a fundamental, elegant law of nature? Or is it literally just server lag, built into the code to keep the simulation from crashing? If you've ever played an open-world video game, you know the computer doesn't generate the entire world at once. To save processing power, the game only renders the exact objects your camera is looking at. Everything behind you simply doesn't exist. If our universe is a simulation running on a server, it would absolutely use this exact same optimization trick to save memory. And incredibly, we have an entire branch of physics dedicated to studying this exact phenomenon: quantum mechanics. In the quantum realm, before you measure a particle, it doesn't have a specific location. It exists as a blurry cloud of probabilities, but the exact moment you look at it, the cloud collapses. It snaps into a solid, rendered pixel. This is the observer effect. To prove this, physicists performed the most famous and frankly terrifying experiment in history: the double-slit experiment. If you fire single electrons at a wall with 2 tiny slits, they act like a wave of water, passing through both slits at the exact same time. They create a complex, multi-striped interference pattern on the back wall. Because nobody is watching, their code remains unrendered as a wave of probability. But what happens if scientists put a tiny camera right next to the slits to see exactly which hole the electron goes through? The moment the camera is turned on, the universe knows it is being watched. The electrons instantly stop acting like a wave. They act like solid physical bullets, creating just 2 simple lines on the back wall. By simply looking at the experiment, we forced the universe's server to render the probability cloud into a solid object, which means, right now, the things behind you might just be a blurry wave of mathematical probability, only popping into physical existence the exact microsecond you turn around to look at them. If the observer effect is the universe saving memory, Then there is another phenomenon that looks exactly like a shortcut in computer code. Albert Einstein famously called it spooky action at a distance.
Truly spooky
Today,
action at a
physicists call it
distance.
quantum entanglement. If you take two particles and entangle them, their states become permanently linked. If one spins up, the other spins down. Now separate them. Keep one on Earth and send the other one billions of light years away to the very edge of the universe. If you observe the particle on Earth and force it to change its spin, the particle at the edge of the universe will change its spin too. Not a year later, not a second later, instantly, at the exact same microsecond. This completely breaks the universal speed limit. Information somehow traveled faster than the speed of light. How? Physics struggles to explain this, but if you ask a video game programmer, the answer is incredibly simple. In a computer, physical distance isn't real. It is just a variable, a number written in a line of code. On the screen, two objects might look like they are on opposite sides of a massive galaxy, but deep down in the server's RAM, the data for those two particles are just two adjacent lines of code sitting right next to each other. When you update the variable for one, the computer instantly updates the other. Zero delay, zero travel time. Quantum entanglement isn't magic. It is simply two rendered objects sharing the exact same pointer in the universe's memory. Optimization, resolution limits, server lag, and shared memory pointers. If our reality looks exactly like a computer program, then we have to ask the ultimate, terrifying question. Who built the machine? To build a computer capable of simulating a universe, you need an unimaginable amount of energy. Enter the Kardashev scale, a method of ranking civilizations by energy use. A Type 1 civilization harnesses all the available energy on their entire planet. A Type 2 controls their entire star, perhaps building a massive megastructure like a Dyson sphere to harvest 100% of its light. And a Type 3 civilization, they control the energy of an entire galaxy. To us, they would be indistinguishable from gods. But what do gods build? What exactly requires the harnessed power of billions of stars? The ultimate computer, a megastructure known as a Matrioshka Brain. It is composed of multiple nested Dyson spheres, like a Russian doll. The inner layer draws extreme heat to process data, passing the waste heat to the next layer to power more computing. A computer this massive wouldn't just run simple physics models. It would have the computing power to flawlessly simulate billions of entire universes, including every star, every planet, and every perfectly conscious, thinking mind inside them, living out their normal digital lives. Which brings us to the ultimate statistical nightmare proposed by philosopher Nick Bostrom, the simulation argument. If we assume that advanced civilizations don't destroy themselves, and they eventually decide to run ancestor simulations for science or entertainment, then they wouldn't just run one. They would run millions, or billions, simultaneously. Because computing power is cheap, this means for every one base reality that actually exists, there are billions and billions of simulated realities. If you are a conscious being existing right now, statistically, the odds that you are in the one base reality are practically zero. Mathematically speaking, you are almost certainly a simulated consciousness, running on a Matrioshka brain, built by a civilization we cannot even comprehend. Before you fall into a permanent existential crisis and stop paying your taxes, take a deep breath, because physicists have a massive counterattack. There are fundamental mathematical flaws in the idea that the universe is a computer. And the biggest flaw is the concept of infinity. Take a perfect circle. In order to calculate the exact circumference of any circle, you need to use the number pi. But pi is an irrational number. Its digits go on forever without ever repeating or ending. 3.14159 to absolute infinity. A computer has a finite amount of RAM. It physically cannot store an infinitely long number. It has to round it off at some point to save memory. If the universe was a simulation, truly perfect circles couldn't exist. At a microscopic level, orbits and waves would look jagged and pixelated. But every test we've ever done shows the universe is incredibly smooth. And this rounding error leads to an even bigger problem: chaos theory. In a complex system like weather, a microscopic change at the beginning causes massive, unpredictable changes later. The butterfly effect. If a simulation rounds off a number over billions of years, that microscopic missing data would compound. The physics engine would drift and eventually collapse. But what about the video game optimization trick? Rendering only what we look at. That doesn't work for the universe. Take the core of the sun. Nobody is looking inside it. But if the server stops calculating the trillion-degree fusion happening at its center, the gravity holding our solar system together would vanish, and the planets would instantly fly off into the dark. The universe can't cut corners. It has to simulate everything, all the time, at the quantum level. To perfectly simulate the quantum states of just a few hundred atoms, you would need a computer larger than the entire known universe. A Matrioshka brain isn't enough. Not even close. The simulation overlords have a hardware problem. We might just be real after all. So we aren't a simulation. We are base reality. But that leaves us with a massive, glaring mystery. If there is no programmer, why does the universe follow such strict, perfectly logical mathematical rules? If we meet an advanced alien species tomorrow, we couldn't speak English to them. But we could communicate using prime numbers. Math isn't just something humans invented to count apples. It is something we discovered. It is the fundamental language hardwired into the fabric of reality itself, governing everything from snail shells to entire galaxies. Which brings us to the fine-tuning problem. Imagine a massive control panel responsible for creating a universe. It has dozens of dials representing the fundamental constants of physics. Gravity, the mass of an electron, the strength of nuclear forces. If you grab the gravity dial and turn it up by just a microscopic fraction of a percent, stars burn through their fuel almost instantly, and the entire universe crushes itself into a dark sea of black holes. No life. Turn the dial down a tiny fraction, and matter never clumps together. Stars never ignite. The universe is a freezing, dead mist of gas. Our universe sits perfectly balanced on a razor's edge. Out of infinite possibilities, every single dial is tuned exactly right to allow life to exist. Why? One popular scientific answer is the multiverse. Imagine a cosmic bubble bath generating an infinite number of universes. Every bubble has a random set of physics dials. Most of these bubbles have the wrong settings and instantly pop, crush, or freeze to death. But with an infinite number of bubbles, eventually one of them will get the exact right settings, purely by chance. Our universe, this is the anthropic principle. The universe looks perfectly made for us because if it wasn't, we simply wouldn't be here to observe it. If we truly are the one lucky universe, sitting safely in base reality, it puts an enormous responsibility on our shoulders. Right now, humanity is roughly a type 0.7 on the Kardashev scale, but our technology is growing exponentially. The smartphone in your pocket has millions of times more processing power than the computers that guided Apollo 11 to the moon. In just a few short decades, we went from 2 white pixels bouncing a square ball across a black screen to hyper-realistic, sprawling virtual reality worlds that are increasingly capable of tricking our human brains. What happens in 100 years? 1,000 years? 1,000,000 years? If we don't destroy ourselves, our descendants will eventually harness the full power of the sun, becoming a Type 2 civilization. We will spread across the stars, building megastructures and advancing our computing power to unimaginable levels. Eventually, frail biology will become obsolete. We could upload our minds into immortal digital bodies, living entirely within simulated realities. A flawless, engineered digital utopia, completely free from disease, suffering, and death. As we approach Type 3 status, commanding the energy of the entire Milky Way, We will build our own Matrioshka brains. With practically infinite computing power and endless time, what will these godlike future humans do? They will run historical models. They will simulate their own ancestors to understand exactly where they came from. They will simulate the 21st century, not just once, but billions of times over, which brings us right back to the terrifying loop. If we are destined to eventually create a perfect simulation, how do we know we aren't already in one? This paradox is enough to make anyone's brain completely short-circuit. It feels like the ground has been pulled out from under our feet. But before you completely give up on existence, let's take a step back and ask a very simple question. Does it actually matter? If you drink a delicious, warm cup of coffee, does it taste any less comforting just because the cup is made of data instead of physical atoms? Hundreds of years ago, the philosopher René Descartes struggled with this exact same paranoia. He concluded with one famous phrase, "I think, therefore I am." Even if your body is an avatar and your universe is just rendered graphics, the fact that you are actively experiencing it means your consciousness is real, your feelings are real. The love you have for your friends and family is real. The pain of stubbing your toe on a piece of furniture is definitely, undeniably real. A perfectly simulated sunset is just as breathtaking as a physical one. The rules of the universe remain exactly the same to us, whether they are made of quantum fields or lines of code. Reality is defined by your experience of it. Base reality doesn't hold a monopoly on meaning. We are the universe, or the simulation, experiencing itself. We get to explore its rules, play its games, and marvel at its beauty. So whether the stars above us are made of burning plasma or intricately written lines of code, the game is still incredibly beautiful. And it is absolutely worth playing. Just maybe take a break from the screen every once in a while. Even avatars need some fresh air. If you enjoyed having your reality completely shattered today, why not rebuild it by getting something from our shop? So, whether this is base reality or a supercomputer's hard drive, let's zoom back out to the ultimate fate of the cosmos. The universe will spend almost its entire existence as a cold, dead, pitch-black void, an endless ocean of nothingness. But we are incredibly lucky, because we don't live in the dark era. We live right at the very dawn of time. We live in the stelliferous era, the era of stars, a time when the universe is vibrant, energetic, and completely alive. Galaxies are merging, and star nurseries are painting the sky. When you look up at the night sky, you are witnessing the absolute peak of cosmic history. Compared to the endless trillions of years of darkness that will eventually follow, this era of light is just a fleeting, microscopic spark. You didn't just win the cosmic lottery by existing. You won it by existing right now. We are the universe waking up. We are the cosmos, growing eyes, ears, and a mind to look back at itself. We've used this brief window of light to build civilizations, compose symphonies, and unravel the very laws of physics. The future of the universe is undeniably dark, and the end of time is inevitable. But that shouldn't fill you with dread. It should fill you with an overwhelming sense of urgency and gratitude, because nothing lasts forever. Every single second of warmth, every sunset, and every shared laugh is infinitely precious. The temporary nature of our universe is exactly what gives it meaning. We are the fleeting spark in the endless night, and we should shine as brightly as we can. Wow, that was a lot to take in. If your brain feels like it just went through a quantum spin cycle, we highly recommend grounding yourself back in base reality with some of our beautiful merchandise. We have stunning, high-quality posters of the universe's timeline, so you can track the end of time right from your bedroom wall. Or, if the existential dread is still hitting you hard, hug one of our super soft black hole plushies. Don't worry, It won't spaghettify you. Making a 30-minute animation about the fundamental nature of reality takes an unbelievable amount of time, research, and energy. Every single poster, plushie, or pin you buy directly pays the salaries of our incredible team of artists, researchers, and animators. It is literally the only way we can keep making these massive, deep-dive documentaries available for free on the internet. If you can't buy anything right now, that is completely fine. You can still help us out immensely. Just hit that subscribe button down below to join our community, and make sure to ring the notification bell so you don't miss our next ascent into cosmic madness. We explore the universe because it is beautiful, terrifying, and absolutely worth understanding. So keep looking up at the stars, keep asking impossible questions, and never lose your curiosity. As always, from the bottom of our rendered hearts, thank you so much for watching.